Most dead circuit boards are not mysteries. They fail in the same handful of ways, and a fixed 5-step routine catches almost all of them before an oscilloscope ever leaves the shelf. In the next 5 minutes, I'll give you the exact sequence I've used for 15 years, from small hobby boards to industrial equipment. First, why a system at all? Because random probing feels like work but measures nothing twice and rules nothing out. A fixed sequence does the thinking for you. Every board gets the same checks, in the same order, every time. When a check passes, you've eliminated a whole category of faults. When one fails, you stop and dig there. One safety rule before we start. Everything in this video happens on low voltage circuits with mains disconnected. Never work on energized mains or high voltage equipment. Step 1. Look. No meter yet. Magnification and good light. You're hunting for burn marks, bulged or leaky capacitors, cracked solder joints, corrosion, and broken connector pins. Half of all faults are visible if you actually look, and 30 seconds here regularly saves an hour of measuring. Tilt the board under the light. Cracked joints show up as a ring around the pin. Step 2. Power rails. Meter on DC volts. Black probe on ground, and measure the supply rail at the board, not at the adapter, not at the plug. You're asking one question. Does the right voltage actually arrive? A 12-volt rail reading 12 volts passes. Reading 0 or reading 5 volts because something is dragging it down, and you've found your neighborhood. Most dead boards die right here at step 2. Step 3. Fuses. Fuses and connections with the power off this time. Continuity mode, the beep setting. Pull the fuse out of its holder and probe both ends. Beep means good. OL means blown. A fuse can look perfect and still be open. The break hides inside the end caps. Then beep every connector and cable in the power path. Harnesses fail more often than boards do. And remember, a blown fuse is a message. Something made it blow. Find the cause before you fit a new one. Step 4. Heat. Power briefly on, then off. And use the back of your finger near, not on the components. Overheating parts announce themselves. A scorching hot regulator, a warm capacitor that should be cold, that unmistakable burnt part smell. Heat is the fault waving at you. A component that's hot with no load is telling you where the current is going. Step 5. Ground. Power off. Continuity between the board's ground point and the supply's ground return. A bad ground is a great liar of troubleshooting. It makes every other measurement read wrong. So voltages look crazy and you chase ghosts. If your readings make no sense, check ground before you doubt your meter. Quick example. A 12-volt LED strip completely dead. Step 1. Looks clean. Step 2. 12 volts at the supply output, but 0 at the strip connector. That's the neighborhood. Step 3. Power off. The inline fuse beeps fine, but the connector pin shows no continuity. Corroded pin, open circuit. Clean it, reseat it, strip lights. Total time about 4 minutes. No scope, no guessing. The sequence one more time. Look, rails, fuses, heat, ground. Same order, every board. If you want this as a printable step-by-step checklist for your bench, my beginner circuit troubleshooting guide is $2.99 at payhip.com/the Circuit Toolkit. Link in the description, along with the full beginner's guide. Follow the Circuit Toolkit every Friday is a new 5-minute training. See you at the bench.